So we have looked toward the calculation of pH of acids. What we have done a strong acid, weak acid, strong acid plus weak acid plus weak acid, and polyprotic acids. So now we're gonna look about the pH of bases, including all these like weak base and all. The case is similar to like acid, but what in acid the acid gives H plus, but in case of base the base give OH negative. So first we will gonna write the pH of bases. So first of all we gonna write case 1. Strong base. Whenever we have a strong base, how do we calculate the pH? Now we're gonna look at like when aqueous solution of any strong base, all the OH negative we will consider it will coming from a strong base only. In aqueous solution, all the bases are coming from a strong base until it is very dilute. Very dilute means the concentration is less than 10 to the power negative of 6. So when it is more, as we have seen in case of acids, the contribution of water will also include. So now we are calculating the pH of following. Now again, as always, I tell you to pause the video and answer by your own. First of all, calculate the following 10 to the power minus 2 molar NaOH. NaOH will dissociate into Na plus and OH negative. So initially it was 10 to the power negative 2 molar. Now it is 10 to the power negative 2. It is 10 to the power negative 2. So POH is what? Negative log of OH negative. So negative log of log base 10 to the power negative 2. So POH is 2 and pH will be 14 minus POH. That is 14 minus 2. That is 12. Now in second, 5 into 10 to the power negative 6 of calcium hydroxide. So calcium hydroxide is there. It will form Ca plus 2 OH negative. Right. It was 5 into 10 to the power negative 6 molar. It was initially 0 when it will dissociate completely because it is a strong acid. So it will give 5 into 10 to the power negative 6 molar of calcium hydroxide, but 2 into 5 into 10 to the power negative 6 molar of hydroxide ion, OH negative. So it is 10 to the power minus 5 molar of hydroxide ion. Now POH is again negative log of H plus, OH negative. Some people might be mistake that they write pH equals to negative 10 to the power negative 5. But you have to look that it is OH negative. Now we can calculate POH first. Or we can calculate H plus also by using KW divided by OH negative. So that is not difficult thing. So simple. Negative log of 10 to the power minus 5. That means POH is 5 and pH will be 9. Now third case, when you have given 10 to the power minus 8 molar NaOH. When it is 10 to the power minus 8 molar NaOH, then what you will do? You will writing as POH as 6.97 and pH as 7.03. How? I'll strongly suggest you to see the calculation of pH of a strong acid. There we have seen when the concentration of H plus is greater than the 10 to the power minus 6 or equal to 10 to the power minus 7 or 8, then we include the H plus concentration for water. Similarly, case of base, H2 is also coming from water. So I am not going to repeat that derivation again. You can solve, see that we have solved a quadratic equation using common ion effect. So I am just writing the results. Like here we have concentration of NaOH in the sources of OH negative. What are the sources of OH negative? Here we have POH and here we have PH. So NaOH, when it is 10 raised to power negative 6, what is the source of OH negative? It is NaOH. And what is the POH? 6. And what is the pH? 8. When it is 10 raised to power negative of 7, the source of OH negative is NaOH plus H2. Water is also included. So P and you can see the concentration of OH negative is 10 to negative 6. The concentration of, and in this case the concentration of OH negatives comes out to be 1.62 into 10 to the power negative of 7. So as we know, the pH was 6.79. In that case, POH will be 6.79 and pH will be 7.21. Here the concentration of OH 10 to the power negative of A. Again the source is NaOH plus H2. It is 1.6 into 10 to the power minus 7. So POH will be 6.97 and pH will be 7.03. Now NaOH is 10 to the power negative 9. Source of H plus only water. So pH is 7 and POH also both are 7. But if some question is given like pH of 10 to the power minus 9 molar NaOH. If A option is given 7, B given greater than 7, C given less than 7, D like can't be predicted. So you need to think. We have some traces of base. So pH cannot be exactly 7. It could be 7.00001 can and may, but it must be greater than 7. So the option will be C. Here we are writing 7, but it is actually 7.00001 pH and pH is 6.9999. It could be like this.